live, probably.
Maybe.
It says
There we
going
go.
live.
It says we're live.
There we go. Now we are live. Excellent.
We are in a state of living.
We are in a state of being live, maybe. I'm going to move that over there. And I'm going to put that there, I think. I just remembered I forgot to install the battery analyzer, so we'll do that. We'll do that as we go if we need to.
Yeah.
So yeah. Anyway, hello everyone. How you all doing? I'm behind the camera today because we're using the bench cam. So I'll bring that down a little bit. There we go.
Yoop.
So now I'm kind of visible. Who cares? Anyway, hello. How is everyone? Afternoon. Hello everyone. Loving the thumbnail this week. Well, I went through a phase of just lipoing everything a while back when I was learning about lipo cells and stuff like that, and so and like Caradog is also a fan of putting lipo into things that don't need to have lipo in them. That's a correct thing to say, isn't it?
Yeah.
Yeah, you're at the very least you're a fan of lipo as well.
Absolutely.
So it's just today we are continuing the quest of lipo all the things. So yeah. So good. Thank the Lord. It's Two Guys Talk Tech. Hello, Chris. How's it going?
Hello.
I want to make a request to you today, Chris. Stop suggesting can of cider in the suggestions every week. We get it. Yeah. Anyway, you have lipo in your name. You do. And you got a full coffee here. What's up, ZX Spectrum? We too are coffeeing at the moment. The Saturday usuals. Caradog, did you remember to pick up Old Rosie this morning? I don't know. Did you get any Old Rosie?
No.
No, that's fine.
I did not.
That's fine.
However.
I mean, we've still got the...
I was going to say, however.
That would be particularly funny given that we're messing about with lipo today to get the alcohol out for that. We'll put it there as... Oh, hang on a sec. Let me turn off the Brio a sec. There we go. We'll just leave those there as Chekhov's gun. So, yeah. We'll just leave that there as Chekhov's gun. All the stations. So, yes. Good. Anyway.
Afternoon.
Oh, yeah, and fake and all that. Good. Hello. How's everyone doing? Yes, we are here. I'm slowly waking up. I'm drinking this coffee. So, yes. Another week, another things to do. I guess... Let's start talking about stuff. And if Oldie Ghetto Cider, how dare you?
It's from Lidl.
Yeah. That's the same thing, right? Where were we? Yeah. This is my door chime. Oh yeah, hang on a sec. Brio. Bam. This is my door chime, and let's start off by explaining the problem to you guys. I haven't tested this beforehand, so let's see how this goes. Oh, interesting. OBS, YouTube is complaining about our keyframe frequency. That's fine. Let us know if there's any issues with the stream today, because Studio is complaining that my keyframe frequency isn't very good. However, I'm using... Oh, no, I'm not using the YouTube recommended settings, actually. That's fine. Let's see how it pans out. Anyway, you're not a fan of lipo because the balloon ones are not fun to have around. Well, it's funny you should say that because, yeah, we've got some spicy pillows over here, just for no particular reason. We were going to be talking about lipo today, and we had some spicy pillows to hand, so we're like, let's just keep those there. Anyway, here's the problem with the doorbell. I don't know how loud this is going to be, so here goes nothing. It was better than that the last time I used it.
Wow! Oh boy.
It was better than that yesterday. I need to hear that again, I'm sorry. That was it. We didn't get a second one that time. Oh. The battery's flat. So,
oh boy.
Of course, I could just put some new button cells in it, which is what I should do, but that's terribly, terribly boring. So yeah, we thought we'd do something a bit silly and make this a Lipo powered door chime. So the door chime is important because it lets me know when the door is open. So it means I can go out the back and make a coffee without going, "Oh, is anyone come in?"
I thought you were saying it makes it important so people know when they've opened the door.
Yeah, I nearly said that, and then I caught myself in time. So,
although based off of some people, they need notifying that they have in fact opened the door.
Now and then you get the weirdos come in who will just stumble through the door, and you'll be like, "Oh boy, here we go," and they're just like, "What are you doing here then?" And I'm just like, "We fix computers, sir. How can I help you? You don't seem to have a computer. Please go away now." So, anyway, let's have a look at this thing. So what we're going to do, we're going to mess around, and some of this may be obvious to other viewers, but hopefully other people might learn a thing or two by watching us dissect some things. So what I want to do, I want to make this thing USB rechargeable, which is completely unnecessary, but I think it's very funny to make things USB rechargeable that don't need to be USB rechargeable. So I'm going to show you how we do that. I've actually done videos on how to do this before.
Videos on making USB rechargeable door chimes?
Well, not door chimes, but I've USB rechargeable widgets. I've got a series on the channel called How to Lipo, which is just a crash course in stuff. Is it going to be USB-C? No, we're going to be using USB micro like a peasant. So no Type-C on this, I'm afraid, just micro. But we'll survive. I don't know how long I'm actually going to use this thing anyway. It might get replaced. This was supposed to be temporary when I got it anyway, because I want a door chime that's actually I want a remote door chime. This one sits above the door, and that kind of means that when it's loud enough to hear out the back, the customer walks in just like, "Oh!" when the chime goes off. But if I make it too quiet, I won't hear it from the back door, which is no good. So I need a remote one so the actual chime is situated at the back of the shop where I need to hear it. So, anyway, a bell on string has evolved, quite so. So let's look at what's going on with this thing. So this thing runs on 4 of these button cells, and these are LR44s. And at the moment, let's our cell voltage.
Soda.
Our cell voltage, oh blimey, that really has tanked overnight. It's down to 2 volts. So these cells are 1.5 volts each. These cells are 1.5 volts each, so there should be 6 volts across there. And if we measure the voltage, it's building back up again where they're slowly recovering. But could you hold the black probe for me a sec, Tar? So what we'll do now, I'm going to grab
not just... Oh,
no, the battery test doesn't seem to work. It's supposed to, but if I wave this magnet near it, you'll see the voltage tank. So you see it tanks when it actually has to do something. And then it slowly starts recovering again as the cells recover. Although I think we may have just killed it entirely. I think we might have just dropped below critical. Oh, there it goes. It's coming back again. So yeah.
How bizarre.
So that's cell recovery in action, and that's why batteries will die. But if you leave them to one side for a bit, they recover a bit, and that's cell recovery in action. It's a bad cap. Yeah. Oh, I forgot to tell you about that. If we have time, that's actually something I wanted to do. I've got some capacitors here, and I wanted to put a big electrolytic capacitor in parallel with the buzzer to see if it makes some funky noises. Because instead of going doo-doo, doo-doo, like it's supposed to, it might sort of go doo-doo, doo-doo, which will be really, really funny to me. And I want to see if it'll do that.
Oh, Lord.
So... Anyway, but first we're going to lipo power it. So by the way, we're kind of... Here's a MacBook Pro battery that I removed earlier on today.
I'm sure one of these will be the right connector.
Possibly. I can't remember which way round it is on these. There's a couple of B pluses and some minuses there. But yeah, we've got this to one side just so...
I have stolen the things with the
you've
sticky.
stuck to everything to the bottom. We've got various other things on hand, so if we run out of stuff to do, we're just going to start tearing apart batteries and going, look, here's how a battery works. So yeah, will it fit? So also, if anyone has stuff they want to talk about, do give us suggestions in chat, by the way, because we're just dicking around this stream. So yeah, at any rate, so to modify our charger, so there's the first thing that we could do here is here's a bare cell that's actually from a MacBook Pro battery. If you bring that back into shot set, Cowdog. There we go. So here's a cell that I actually stole from these. As you can see, here's one of the ones from there. And I've actually taken this off and put some separate wires on it. So I have a bare Lipo cell. So for starters, this is 3.7 volts nominal. However, at full charge, it's actually 4 volts. But obviously, you might say to yourself, well, if there's 6 volts across these button cells, surely a single Lipo cell isn't going to be enough. But as you can see, as you can hear, this thing just about is still making a noise at 2 volts. And 3.7 volt nominal is actually plenty enough to drive it if you've got the current capability. And the problem with button cells like this is they've got no current capability in them at all because their capacity is so small. Hammer and nail. Hot glue the Mac battery to the back of the Chime. Well, that's the first thing we're going to do, just for the sake of demonstration. So,
interestingly, though, this says 3.7 plus on it, on there.
Yeah.
These ones all say 3.8 plus.
Oh, that's interesting. I wonder if they changed it, or this might not be a genuine Apple cell. Maybe this is from a third-party battery.
Yeah, but just interesting.
Yeah.
It's the same watt average. Actually, it says it's a higher watt average.
Maybe they changed the battery structure at some point in the MacBook Pros.
8156. Interesting. Yeah, I think it's from a slightly different year. Just because the dimensions are fractionally different.
Okay, yeah. Fair enough.
It's just interesting that they list a different nominal voltage.
Yeah. Oh well. Did I open the indoor window so we can see the front of the door from where we are? Yes. I haven't done any behind-the-scenes videos for a while. Again, sorry about that. But if you check the behind-the-scenes videos, because if you've seen any pictures of the shop of the new shop at all, I'm assuming that you have been a channel member or something of that ilk at some point. And yeah, in one of the channel update videos, I show all of the interior of the shop and stuff like that. 100,000 subscribers special coming soon. It will be public soon. I've just got to tidy up.
Which made good headway last week. Because you cleared a whole bunch of your queue out, didn't you?
Yes, I did. Yep, I was going to start tidying today. I was just too tired, basically. I'm really tired today, and I don't know why. But yeah, Carol could easily do voiceovers for kids' cartoons. Huh. The quick brown fox jumps over the lazy dog.
Does it?
Fair enough. I don't know. Does it?
Occasionally. It depends.
It has been said recently in the news. the rumour come out.
Oh dear.
That's an obscure reference that someone will get. Don't forget to make it IP67 rated. It's funny you should say that. I mean, if I get
have you got a whole bunch of hot snot or something?
No, but I've got some big heat shrink. What if we just heat shrink the entire thing afterwards? What's that worth?
Surely, though, that will make the sound...
Well, I do actually usually have some tape over the top of it because it's too dang loud normally. So, right, the first thing I'm going to do for the sake of demonstration is I'm going to solder this this JST connector onto the terminals just so we can I can plug in. Because when I have bare Lipo cells like this, I put these JST connectors on them just because it makes them easier to work with.
Have you confirmed that there's actually any charge in this?
Yes.
Okay.
Yes, spoilers, I actually tested this yesterday just to make sure that we wouldn't just get into a situation where I'm just like, oh, none of this is working and everything is broken forever.
Everything is awful.
Yes, I did actually pre-charge. Oh, this I hadn't charged, but it was already charged. It was like 3.8 or something like that. Okay. It was fine. This tiny little cell, I have pre-charged this because, like, I don't really want to bang an amp into this, so I was like, I'm going to pre-charge it because I don't want to charge it at any more than 300 milliamps because it might explode. Which is actually something I should test because I've got a couple of those kicking around, and I actually want to see what happens if I try and bang an amp into one of those.
It will take it once.
Yeah, that's the problem. Because where it's a 200 milliamp hour cell, obviously, like I wouldn't recommend going harder than 300 milliamps, maybe 500 if you want to thrash it.
I wonder if you could find a spec sheet, because there should be a C rating for charging. And, like, these cells...
I mean, how would you find a spec sheet for that, though? Yeah, that's the thing. It's just a no-brand cell. I mean, we've got the dimensions and the voltage and the capacity on it, but that's all we know about it. Unless EHAO means anything, I don't know. Do you know if that means anything?
I haven't.
Yeah, or I wonder if that barcode would decode to anything interesting. But yeah,
it's like these cells, just obviously these ones.
Yeah,
that are out of hobby stuff. They've got a charge rating of like 5 or 10 C. Yeah,
which is low by modern standards, isn't it? Although I don't know how much batteries fib about their C rating. But
also a case of, don't forget though, that this is a 3000 milliamp hour cell. Yeah, so you can charge it at 30 amps.
Yeah, true, yeah.
Because it's 10 times 3.
Oh, I see, yeah. That's not the C rate. Yeah, that was for the cell, not the battery as a whole. Yeah.
That's the charge speed.
Yeah, because my 4-cell LiPo says 40C on the side, and I'm just like, that's probably discharge, but even still, I'm just like, I don't know if I want to charge it at anywhere near there. I think it's down there. I can see my Tomtac down there. That's that's 20.
That will be the discharge rating.
So I'd imagine the charge rating is probably at least 10C on that.
It's dumb how much power you can bang into LiPos.
Yeah. It depends on how long you want them to last, really, isn't it? Is this even hot? Yes, it is.
Melts plastic. Ah, yes. This is indeed hot.
Yes. Right. I pre-soldered this last night, so there's actually some solder on these terminals already. So for the first demonstration, that'll do. We're going to take that off again in a minute anyway.
Oh, you went just straight onto the connectors.
Yeah.
That's cool. I almost expected them to be hard to solder to.
No. Are you awake now?
Are we waking the dead?
So yes. Look at all this prep work I've done. I know. But hold your... Sorry. Sorry. Here's all the owls in chat. I'm just going to get some...
And here's me going, I thought you had a limiter.
Yes, but that's a very harsh noise. Let's just... shh. No more tears, only... Sorry. Oh, it's a dodgy connection to the battery. Thank you. I wonder if... Can we smother that anymore? I don't know. Let's try a couple of layers. Right, here we go. I'm going to try it again, everyone. Right, this is... Yeah, sorry. The tape does nothing. Okay. We'll figure something out. Well, as you can see, with the single-cell LiPo onto it, it's now sounding very healthy. Even though that is still at full tilt, this thing is still 2 volts below what it should be. It clearly works just great. So what this tells me is that this thing is ideal for a LiPo conversion because it doesn't need any voltage conversion on it. So the reason why I do this demonstration, were you about to say?
I was just thinking, does that mean that when this actually triggers, when it's got these cells, that actually it drops from 6 to like 4 or something?
I don't know. It might do. Because when I was doing my How to Lipo series, one of the demonstrations I did was I had this novelty Mario coin block toy. So it was a little keychain toy that was in the shape of a Mario coin block, and you push it and it makes the coin noise that goes ding, and it made that noise and it lit up. However, and it took 3 button cells. But the irony is the 3 button cells didn't have the current capability to power it properly. So it was actually it out of the packaging. With brand new cells in it, it actually sounded really sickly. It was kind of like, ding, kind of thing. and like the lights on it didn't come on very brightly, and so it was quite possible that thing was actually tanking in voltage under the current load. We could actually test this now by sticking some new cells in there.
Yeah.
So let's do that.
And probe and probe.
Let's do this. So just before we get to that, I'll just quickly show you why I'm interested in this.
The other thing that would be interesting, is doing it now with the Lipo on there. So we've also got a comparison.
Oh yeah, sure. Yeah, we'll do that in a sec then. So yeah, the reason why I bring this up is this is my component tester, which has appeared in various videos, and this component tester, normally this is supposed to run off a 9-volt battery that hangs off the side of it. However, I did a LiPo conversion on this because I'm like, I don't want to plug in a battery every time I want to use this. So this is LiPo converted. And what I did for this one is we have a bare LiPo cell. I've got a charger module, and I'll tell you about these in a moment because we're going to show off one of these for this doorbell. And this is a DC-DC boost regulator. And that is boosting the 3.7 volt nominal from the cell up to 9 volts to run the widget. And so this has got a little boost converter on it, and that little potentiometer there sets the voltage. So I've pre-configured that to go up to 9 volts. So it takes whatever the output from here is and boosts it up to 9 volts, and thus allows me to run a 9 volt device from a 3.7 volt nominal cell.
That's cool. Can you also then run this off of a power source in there? So if you've got power in, does it still turn on?
Yep. So I can plug USB micro into there. Even if the cell was stone flat, I can plug USB micro into there, and it will have 5 volts, which will then get boosted up to 9. And this is a regulated output. So if the cell is flat at 3 volts, it will still boost up to 9 volts. And if it's chock full at 4.2 volts, still boosts to 9 volts. So it's a regulated 9 volts.
I see.
So yeah.
And is it doing that effectively dumbly without sort of logic in there? So does it know what its input voltage is, or is it just a case of
it's watching the output is what it's doing?
But it knows what the output is.
Yes.
Something knows.
Yeah.
Right, okay. So it's not a entirely passive.
Yeah, that's right.
Feedback or something.
There's a chip on this. I've no idea what this chip is. I'll get a big old close up of that. Maybe someone will know what it is. Hang on a sec. I don't actually have.
Detect settings.
Yeah, let me get the thing open. Brio, zoom, autofocus. There it is. I'm still new to Logitech settings. Focus. There it is. So that little chip. Let me grab a pointer. Whoop. So that guy there is controlling this, and what it actually does is we've got the plus rail. It comes into this inductor, and this chip shorts the output of the inductor to ground, which causes a sudden rush of energy into the inductor. So the inductor charges up, and just as it's going because it's in a short circuit, the chip then switches off the short circuit, and all of that energy then goes through the output as a higher voltage. So that's how it's boosting low voltage to high voltage, and it does that very quickly.
Oh, I see. Oh, it is literally doing it.
Yep.
A la VRMs.
Yeah, that's right. It's the opposite.
Right, but the opposite way round.
Yeah. The VRM is a buck converter. I don't think this classifies as a buck converter because it's step up, not step down. Yeah. But the principle is the same.
Right. Oh, I see. Okay.
It's a switching power. It's a switching device. So so yeah. And so this is known as a DC boost converter.
So, excusing my ignorance, how do I? Because you can have non-switching voltage step up and step down. Yeah. Is that just using a transformer? Just using coils?
Yes, and I think in order to do linear transformation, you have to be in AC, if my memory serves me.
That would make sense because
at the very least, I think DC transformers have horrifying efficiency.
Right.
And this is why.
Right. Oh, I see. That's why all of the LED lights and stuff are all switched.
Yeah. And in the good old days, in the long ago, I've got some cracking examples to hand here. Remember Remember when everything had these enormous hecking bricks to run them?
Because I legitimately want these.
Yeah.
I have applications where I require these.
Yeah. So this is a linear power supply, and this has got a heck off huge transformer in it, a big old coil of wire. So it weighs a ton, and you could kill someone with it. You could even swing it around like a mace. But that's not what this video is about. However...
Hello, chivalry.
Yeah, so we used to have those, and then suddenly switching power supplies came in, and now we've got something that's this big. And I mean, look at modern phone chargers, man.
Is the pine saw one a gallium nitride one?
It is.
Is it on top of your pine power?
No.
Oh, no.
It's over here somewhere. Oh, I can't see it, so I'm not going to grab it. However,
But yeah.
I've got just a phone charger here, which is also an example. Just nowadays, like this big old. When I was a boy, when I was a young man, my Game Boy, when I had the mains charger for that, had a big old brick like this on it.
Oh God.
And that was what used to power my
didn't
Game
it?
Boy when I was running it off the mains. But these days, you've got a modern phone charger like this, and that's doing 240 volts down to 5 volts in that.
Yeah. Or 9 volts, 2 amps.
Yeah,
and
or
stuff
9
because
volts,
you've
2
got
amps.
fast charging and stuff.
That's right.
Oh, that's silly.
And that's the magic of switching power supplies, man. Switching power supplies, like, I mean, obviously we were already on switching power supplies by the time I learnt about electronics. But when you look back and you look at what we used to use with these big, massive linear transformers that were doing AC transforming, now with modern DC switching power supplies, you're just like, absolutely amazing.
Yeah, but no, I legitimately need linear ones.
Why do you want a linear one?
The switching ones cause interference on the power.
Yes. Switch mode power supplies do create a lot of noise. This is very much true.
Which is not very good when you're using a radio.
Yes, quite so. Yeah.
But guess what? Modern radios come with switch mode power supplies.
Yeah. There's probably a whole science to reducing the switching noise of switch mode power supplies.
I'm sure you can stick, the back EMF diodes and the taps and the X's and the Y's and the...
Yeah.
But that is way beyond my pay grade.
Yes, quite so.
And I'm like, or I could just get a linear one.
Yeah. So yeah. Anyway, okay. So this is the kind of thing that we're working towards. A simplified one, but as an example, this is stuff that you can do, and this is why we're interested in. So the reason why I wanted to know whether this would work on the bare cell was because it tells me whether we would have needed some kind of boost converter for it. Because obviously, this being a 9-volt device, there's no way this thing is going to run on a 3.7 volt nominal cell. And even if I put 2 cells in series, we'd be at 7.4 nominal, which is still a bit, and that would be 7.4 nominal sagging down to like 6 and a bit, high 6s when it's flat. So that still wouldn't be enough. We'd have to go to like a 3-cell arrangement, and then you'd need to regulate that because now you're up at 11 volts, which is too hot. And so this solution, we go low and we boost it. The only thing we got to watch out for is when you boost the voltage, the amps go up as well. So
you're boosting your draw amps.
That's right.
Because watts have to be maintained.
That's right. So when I boosted the voltage for this, I had to make sure that this cell would be able to handle the higher amp draw, which I tested and found that it could. Because as discussed, we were talking about C numbers earlier on. That is how many amps you can draw from the cell at a time. And obviously, this thing only probably. I did tests on this at some point. I think I made a video when I lipoed this. I can't remember. But I did actually run tests, and I found it ran on something like 250 milliamps or something like that.
See. Yeah.
And it's just like, 250 milliamps. Oh, you're laughing. But when you boost 3.7 up to 9 volts, 250 milliamps becomes like an amp. And it's just like that's a big hike in power draw. However, a cell like this laughs at a cell like this will laugh at an amp of current draw, no problem at all.
Well, yeah, it's the things we're saying about like the hobbyist ones. They're building packs where they're like, oh yeah, the peak current output is 400 amps, and you're just like, oh my god.
Whenever I've spoken to someone who's into drones, they're like, "Oh yeah, it pulls about that. One of my rotors is pulling about 100 amps when I start taking off with it," and I'm like, 100 amps, bloody hell! But yeah,
you're just like, oh, okay.
Yeah. So anyway, that's the widget. So so let's test some voltage drops because that's kind of interesting. Let's test that.
Hello.
It's the Popo. Right.
Oh crikey! It's the Rosas.
Okay. Right. Do you wanna probe, and I will do the thing. So if you can get comfortable with the probing, and then I'll deafen everyone.
Hold on, that can literally just rest in there because of the way that is.
Yeah, however you want. We're going to be we're the wrong way around, so we're going to be at minus, but that doesn't matter.
Oh, hold on. This can be resolved.
Yeah.
Magically. By the power of yoink. There you go.
Okay.
We're at 4 volts.
All right. If you can adjust so you're not blocking the camera.
Yeah. I'm just going to swing
where's
around.
my magnet gone? Oh, that's fine. I'll get another
Hold
one.
on. Where is... There.
Ah, there it is.
So if I put that there, my hand is not in the way.
Welcome to my world. There we go. There we go. So 4 volts. So let's see if that voltage dips at all when it goes off. Hold on to your ears, everyone. Noise warning. 3, 2, 1.
Oh yeah.
Oh yeah. Those. It recovered a bit. Yeah, there you go. So the load did actually pull it, but man, it was millivolts.
Yeah.
It pulled it down slightly, but it was by millivolts, so just
cool.
Basically meaningless. Whereas these little button cells, it was pulling it down by volts, entire volts at a time. Huh. But yeah, there you go. We did actually see a little ripple in the voltage there. And fun fact is that you can actually do very interesting things by watching the voltage of a battery. There's a fascinating attack which doesn't actually work on many devices these days, but whenever you see pin number combination safes where you're trying to break the pin number on them, there's a fascinating attack where you connect a oscilloscope to the battery terminals, because obviously being an electronic safe, you have to be able to change the battery on it from the front, otherwise you could get locked out. So obviously the battery is accessible. You connect up an oscilloscope, which is just a very accurate multimeter to all intent and purpose, to the battery, and you start pushing buttons and you watch the voltage wobble. And by studying the wobble in voltage, you can work out when it's processing and when it's ignoring. So if you see it push a number and it goes, nah, and then you see it push another number and it goes, nah, and then you push another number and it goes, that was probably the system going, nope, that's wrong, reset and start again. So suddenly you can start brute forcing it. Now, in reality, this doesn't actually work on modern devices. Although there are going to be some absolutely awful trash devices out there that are probably vulnerable to attack. But yeah, so there's actually some very interesting things you can do by watching the way that the voltage of the power supply wobbles under when it's working.
That almost sounds like people decoding passwords by listening to typing sounds.
Yeah. That's right.
And listening to the sound difference in the distance of the fingers.
It's absolutely bonkers, but when you look into it, you're just like, oh my god, that's actually plausible. So, yeah.
Amazing.
So, Mike Casper, are you an amateur radio operator?
No.
Or are you just trying to listen to Radio 2?
No, this is listening, it's not broadcasting.
Yeah, fair enough.
Yeah, it's just a case of the amount of interference and stuff you get out of those power supplies is nutty.
That's true, and if you're in a poor signal area, and sometimes literally moving the power cord away from the radio improves the reception that the radio gets, and if you're struggling for reception, then that's probably the difference between getting a clear signal or not.
Yeah.
Especially with DAB, where obviously it's you either got a signal or you don't.
DAB is hilariously trash. And I cannot believe that people are trying to push it as the future.
Yeah, whereas obviously analog radio, because a little bit of noise was probably buried in the noise floor and could be filtered out by the amplifier and stuff. But yeah, I mean, the advantage of DAB obviously is the fact that you can now have so many channels, which is good. But
is it though? Do we need more radio stations?
I don't know. I don't listen to the radio, so that tells you a thing or two there, I guess. Yeah.
Indeed. Anyway.
DAB, more like BAD. Oh! Okay. Right, anyway, where were we? Now you know how to do crime and stuff. So, where were we? Okay, so yeah, we've seen a voltage drop. Cool. Yeah. So let's stick some new button cells in there and see what the voltage drop on that looks like. So,
will you need to desolder, or do you think we can bodge
I will just desolder it because it takes 10 seconds.
Get in there, cracks.
DAB is mostly mono, really? Damn.
Yes. Yeah. Exactly.
That's terrible.
A whole bunch of stuff like that, and it's at like 32 kilobit on like MP2.
Really?
It's garbage. Tier.
Wow. Yeah, like, oh, yeah. Oh, yeah, that makes me very sad.
Yeah, absolute garbage. Tier.
Yeah, I mean, I think by the time DAB radio was kind of was mainstream, I feel, well, I mean, lots of old dears use DAB radios, but for me, I'm just internet radio, man. Never not internet radio, because obviously you can get high quality wherever you want and whatever channels you want for free kind of thing, but I don't know.
No, these are alkaline. Okay. I thought these were the zinc
thingy,
what's it, air batteries, but they're not.
Probably depends on what you buy. These were doubtless the cheapest ones on eBay I could find.
Yeah.
Because I use those in my calipers, which is why I have them. My calipers take one of these cells, which is very annoying. I wish it took a CR2032 or something. But yeah, I need 4 of these obnoxious things. What about the old ones? Oh, it just doesn't say anything. Yeah. Oh well.
Was it that way around?
It is negative to the left, so it's that way round. Hold on to your ears, everyone. Here we go.
It changes noise?
I don't know, man.
Also, I'm intrigued as what the toggle switch is.
The toggle switch is alarm mode, because this can be used as either a door chime or a door alarm. So you could put this on a window or a cabinet and have it so it continuously sounds while the cabinet is open.
Oh no!
Because that's another thing you might want. That's the mode it was in by default out of the package. So when
you just put it on the door.
Yep, I opened the door and it just was just sort of like, I'm like, stop the noise! It was a comedy act.
Desist!
Yeah. All right, let's probe it again. Hold on to your ears just in case it goes off, or it's going to go off again in a minute anyway. But here we go. There we go. That's a very solid 6.3 there. That's a very confident 6.3. So let's see what happens now. So here we go.
Good lord.
There you go. That was a big drop.
Yeah, I saw 5.4.
Yeah, and that was across 4 cells, man. That's 4 cells to share that load, and we dropped by about 1 volt total. So yeah, that was a big drop. Okay, well, there you go. That was an interesting demonstration. And it's come back up again, yeah.
Yeah, but it's still 0.05 lower.
Oh, interesting, yeah. I mean, obviously, they're 1.5 nominal, so they'll probably drop down to 6 volts fairly soon in their lifespan, I'd imagine.
But it's just interesting that there was a reasonably large drop-off.
And it bears mention, the cells that we've taken out, these are the ones that it came with, and I've only had this thing for like 7 months, maybe. So they didn't last very long either, which is the other reason why I'm just like, I'm going to do something dumb with this, because I know it's going to just burn through more cells. Although that much being said, you don't know how long it was sitting in a warehouse with these cells in it. So these cells could be 5 years old for all I know. So, but yeah, there you go then. So that's kind of interesting. Yeah. Cool. All right. So
but the fact that there was nearly a full volt drop on it being at 6 point something, whereas that's obviously I can't remember what it was.
Yeah, it was a 4 volt. Yeah, it was actually 4 on the dot, I think. Yeah, and it drops by a couple of millivolts.
Yeah. It's surprising. They're obviously showing the current handling capacity difference.
Yeah.
The current handling difference of the two of them.
Yeah.
So yeah.
Oh God. All right. I'll be back in a moment, everyone.
Yeah, of course. Absolutely. But yeah, it's surprising to see that. Interesting. Apparently the buzzers changed tone significantly with the voltage.
I'm in the middle of a live show at the moment, so yeah.
I don't know, Teltac. I don't know if DAB ends up being cheaper on the infra side, but it's just a case that it makes so little sense to me, just because of how much the end user experience is degraded compared to FM, and then requiring users to buy whole new radios to listen to something that isn't an improvement makes, no sense to me.
Or at the very least, for me, it begs the question, why is DAB so poor quality? You know, can they really not get any more bandwidth on the stations than that? Because they seem to be...
The technology is capable, but they run the multiplexes at such low bandwidth, so they can stuff in as many stations as possible.
Like, I can't imagine that there's any shortage of channels on there. So surely you could say, well, you know, conventional radio is pretty thin on the ground these days because of the internet. We're only using half the available channels, so why don't we just half the available channels and double the bandwidth? But
I don't know. No. It's just such a bizarre setup.
Yeah, I don't know enough about it, to be honest. But yes,
it's very silly. But as far as I'm aware, Norway has switched over fully to DAB2, and there are no more FM transmissions.
Yeah, well, so have we, haven't we?
No.
Do we still have analog radio?
Yeah.
Oh, I thought the analog transmitters were all switched off these days.
No, it was just TV that switched over a couple of years ago.
Oh, interesting.
But yeah.
Fair enough. Yeah. Doesn't surprise. It wouldn't have surprised me because I thought we had already switched off. But yeah. Fair enough. Oh well, they want more stations so they can sell more broadcast licenses. Yeah, I mean, who's buying them though? Because that's the thing. Is just I don't know. The problem is, this is one of those things where I'm just like, who the hell even listens to the radio? But I'm just like, I don't know. My family does. Like, whenever I'm visiting my family, they've always got a conventional radio on in the kitchen. And yeah, that's the thing they do. So yeah.
Yeah, exactly.
Yeah. Oh well. Right. So what are we doing with this thing next? So on that note then, I'm actually suddenly concerned whether my little 200 milliamp hour cell that I planned on using in this thing has actually got the grunt for it. So I think we should hook this up and see if it can actually do it.
Yeah. I think the other thing we should do is see what space we've got in the back.
Yeah, that's true. Because if my plan was to try and stuff this and this is so these are TP40 things, and I take one of these guys out. So let's zoom down on all of this, as Big Clive would say. So this is a TP40 module. And it's so called because that chip is a TP40 chip. And this is basically a very simple Lipo charger chip. So what we've got here is we've got B plus and B minus. So we connect our cell up to there. And there's a USB input here. So the USB goes in, and this regulates the voltage to charge the Lipo cell, because you can't bang 5 volts into the cell. You have to put in 4.2 volts and you have to regulate the current and then regulate the voltage and so on. So that charges the cell, and then we've got a power rail here and here. We've got a positive and a negative, which goes to our load side. So that way the load is not directly connected to the cell. And this also means that this guy can protect the cell. So if the cell drops below 3 volts, it can switch off power so we don't deep discharge the cell.
I presume these are all things that are pre-programmed in them.
That's right. This is all just encoded into the chip.
Yeah. So it's also a case of it's not something that's set by resistances or capacitance on a leg or something.
Some of it could be. The charge speed is probably set by one of the... is possibly set by something here. I'm not sure. So most of the... Like, that capacitor is just across the battery. That's just a smoothing. That's probably an input smoothing capacitor. There's a 0 ohm link there. That's going to be that's basically a fuse, that 0 ohm link. These two resistors are for the LED indicators for charge status.
Oh, you have LEDs.
Yeah, so those won't do anything. But there's that guy down there going down to ground. That might be setting something. By default, I think these things do like 500 milliamps or something like that, wow. Which is a pretty safe bet for just a single cell charger.
Yeah, absolutely.
Because if you were charging like an 18650 or something like that, 500 milliamps. It's not fast, but it's fine. You know.
Yeah, it's not going to cause damage.
Yeah. The reality is basically any 18650 or any single cell would probably hack an amp. But if you were connecting up to something small, 500 milliamps is a safe bet. So, let's see.
Yeah.
So yes,
Interesting.
Tiger Videos was using an RT809F for the first time, and it was very good. Good. There's a new version of the software for that out, by the way. Which I think Selfman in the Discord posted that. I actually need to download it on this computer as well, so I need to do that. Good. Right, so let's see. Let's connect this cell up directly and just see if it can actually hack the current draw first. Because having seen that current draw, that's bigger than I thought it was. How could we check what the actual current is on this? Because the problem is it's momentary. We could use max and minimum on this actually. So let's do another test. I want to know what the current draw is. So let's put on the big cell again.
I want to know what love is.
And let's find out how much power this thing actually draws when it goes off. So what I'm going to do, I'm going to get an extra jumper wire.
You have precisely 0 space in the back.
Oh, I see, yes. Yeah, let's have a look. What does that look like inside? Wow, heckin' hell. That's a big old inductor there. That might be where all the power's going to charge that bad boy up. Does this come out? That's an amazingly simple device.
It also almost looks like they went, here, you can stick a coin cell. Here.
Yeah. Possibly. That might be to mount the piezo, the speaker. However, there's literally no controller in that.
I'm also liking the date code.
Yeah, 2005, yeah. That kind of reinforces my idea that these cells are probably super old. That's got several coils on it. This is running some kind of basic oscillator, which is all it's doing there. But I don't know. I'm not going to reverse engineer this here. Oh, they're idiot. There's a controller on the back of it. I saw that and then was just like, oh, look, there's no controller. Idiot. There has to be some kind of controller because it emits multiple tones. Oh, well. I'm not reverse engineering this now live on camera because I'm a dunce and it will take me ages to do that. Anyway, but no, we don't have a lot of space in this. I was kind of hoping this area would be mostly empty and we could stuff a Lipo cell in there. So I'm not sure how that's going to manage. We may end up just bodging something onto the side of this, which I'm at peace with, quite frankly. I don't care. Fine. Okay. Right, what are we doing? We want to see if we can figure out current draw. So let's connect up some wires. So if we disconnected, can I push the? Hang on a sec. Let's remove the tape. The tape does nothing. I'll just cover it with my palm every time I think it's going to go off. Can I push the buzzer out of that without damaging it? I don't know that I can. Oh, it's...
Yeah, kind of. It looks like that might pop off, yeah.
Not sure.
Or is that what's actually holding it? Is it in there?
I don't know. Some kind of press... I have a feeling that might be heat staked, actually. Either way, it doesn't seem to want to come out, so... Oh, that's actually got a longer lead on it if I untangle that. That's better. I can work with that. Cool, let's desolder those wires, and then we can connect them to other things. Set limiter. Oh, there should be already. However, I'll make the limiter a bit more aggressive. Filters. I'll set the limiter to be a bit more aggressive at -6.
-60.
-60 dB.
Hello, we're very quiet today.
Glued in, so only the vibrations. Yeah, that makes sense. Right, here we go.
Today we're looking at a piezoelectric doorbell.
I think that's coming out quite surprisingly well. Right. I've already lost track of where those just came off from. There and there, I think.
Oh, God.
I wasn't looking.
10 out of 10 Pro.
That was plus, and that went up to there, I think.
10 out of 10.
Yeah, those are the only places they reached to, so that must have been it. I was not paying attention at all there. Was the black low? Yeah, the black was low. The black went up there, the red went down there. Yeah. Well, you weren't watching either, so that's as much your fault as it is mine. Do you guys play on VR? If so, what headset? I have not done much of it. Caradog's got a Vive...
Cosmos.
Vive Cosmos.
Yes.
Yeah.
Which is actually...
phone. I should have. Yeah,
it's right there.
Yep, we've got it on hand out the back here. We need to set it up in here, and I want to play with it more.
Absolutely. There was a new game recently that I saw that was out for VR net, and it looked very good. And I was just like, oh yes, should try that one out as well. Entirely forgotten what it's called, but I'm sure if I scroll through Steam, filter only by VR, released newest releases first. That's English.
It'll pop up.
It will pop up and I'll go, oh yeah, that one. Yes. I just like the silly little things that people have done in VR, like Job Simulator.
Yeah. Which sounds really dumb, but also when you go through it all, kind of makes sense. And you're just like, oh, I can understand that, even if it's not my kind of thing.
I like it just because it's an easy intro into VR.
Yes, that's
because
true,
it's very real world grounded activities that people could have completed, would have completed.
Yeah. I'm just gonna grab. I think I've got some probes that have crop clips on them.
Oh, interesting.
Which would be a lot easier for this sit scenario. I saw them recently. I'm not going to look for very long. Or is that them? There we go. Right, I'm really bad at doing current measurements. This is actually an area that I don't know much about, which is why I'm kind of interested in doing this, because it's kind of as a case of, this is cool because we're practicing together. So for current measurements now, we need to be on the amps connectors of the multimeter. So we use the amps side instead. And we're going to put this in, we have to put the multimeter in series with the device. And I think we go, so, oh balls, I needed to measure on the positive for that. Okay, I need to swap those around because I'm in, well actually, no, you can measure from the negative, can't you?
Surely the current would be the same everywhere.
Yeah. Current in, current out. So yeah, that shouldn't matter, right? Yeah. So in which case it will be positive to there, and then negative going back into the cell, I think. Well, if we get negative numbers, we know it's the wrong way round. So I'm going to stick that there, and we're going to go into the amps range. So now we're measuring amps. And let's connect up the cell again. Right, hold your ears, everyone. Sorry.
Right, that did do a thing.
It did do a thing. I didn't see whether it went negative or positive, though. Right. I'm going to get this to a point where I can hold on to it. There we go. Right, let's watch what it does now.
There was a min-max option or something.
I think there is. Let's see, how do I min-max on this thing? Let's check, not range, select AC or DC. No, that doesn't help me. Range doesn't help me. Oh, actually, I've got a feeling this one doesn't have min-max. We'll just watch it, we'll see it.
Okay.
Right. We could connect it to the power supply, but that wouldn't really achieve it. Anyway, here we go. Oh, there we go. It was about 45, 50 milliamps. That's not a lot. I thought it was going to be higher than that for its ability to pull down a cell. But then, on the other hand, the big cell, it was only pulling that down by a matter of millivolts.
Yeah.
It needs a push bike dynamo added. Yeah, that would work. Fine. Okay. So we saw it went up to about the high 40s. So our current draw is about 50 milliamps when this thing chimes or beeps horribly. So, okay, well, now we know. So basically, we're asking this thing to take a 50 milliamp load. Sure thing, that should be able to do that. Okay, cool. Enough. Shush. Be silent. Let's disconnect the cell before something awful happens.
Be quiet.
Are a fine maker of PC peripherals. Alright, I need to now reconnect these wires because my wires have come out of my JST connector. Only the highest quality demonstrations on this stream. I hope this is kind of interesting to people, by the way, because this is just what we're kind of doing, really. How is that? I'm just going to do this off camera just because then I can do it. My hand makes no difference. I love this. It's the classic Simpsons. Like, the goggles, they do nothing. That needs a spot of glue in there. That's a job for another time, though.
Just get the hot glue gun out and just cover the connector.
Right, okay, so what do we... Now we want to hook up this guy. Right, again...
With one of these, I presume.
We don't have to right away. Let's do it without first, just so we can watch what the voltage does, and then we'll hook up the TP40 for our actual solution.
So we want the crocodile clips?
We could do it...
Going to do it with this?
Oh, yeah, we could probe it with the crocodile clips. That'll make it easier to probe. No, actually, I think yeah, those ones will be easier for voltage probing. I'm just trying to decide whether I'm going to put a JST connector on this or whether I'm just going to solder. I think I will just solder it. So let's take that guy off. Heating. Go. Oh, right. High was low. There we go. Right, I'm going to tin these tiny little wires because this thing has really weedy wires on it. Watching two guys mod a doorbell is the reason I'm single. To be honest, I kind of wanted to do it on a doorbell just because it was so arbitrary. Because that's the thing. If you do it on anything serious, people will be like, "You're doing it wrong." Whereas just like no one can possibly tell me that I'm modding my doorbell wrong. I dare someone to tell me I'm doing this wrong. So
on your tumblr.com.
Yeah. Because someone's going to be like, "You're not using flux." Hold your ears, everyone, because it's going to go off. Sound warning. Ooh, that's really piercing to me as well, by the way. You didn't use flux. What I should do now is I should put an entire pool of flux on here and just go across the whole thing and be like, "Are you happy now?
Are you not entertained?
Are you happy?" You need to add a string of for the orally impaired. Oh, see, Mike White, you started on what I thought was going to be a joke and just say you should make it an RGB doorbell. However, a light for the orally impaired, that's a legitimate reason to make it an RGB doorbell. So there we go.
No, it isn't. It doesn't need to be RGB for that.
But it could be.
Yes.
It would please me.
Oh.
Probe this. Not with the tweezers. Do the thing. Voltage. Sound chime triggers RGB circuit. Razer RGB doorbell. Oh no. Make a Braille doorbell.
Surely the most disturbing thing to feel in Braille is "do not touch."
Alright, are you good?
Yes.
Alright.
Maybe.
Here we go. Hold your ears. Sound warning, everyone.
It's a much bigger
not bad.
drop.
Yeah,
But
it dropped by about 20 millivolts or so, which is a lot more than this cell did, but still significantly less than the button cells did. So again, it shows the current capability of Lipo.
Yeah.
Like that tiny little 200 milliamp hour cell has drastically more current handling than 4 of these. That's crazy, man. That's cool. The most disturbing thing to read in Braille is, do not touch, danger of death. Yeah. Don't touch! Are you trying to see how much the size compares? Kind of similar, but then I wonder how much metal is in these, just like for the casing. Because one of the great things about Lipo sort of flat cells is how space efficient they are.
Yeah.
But yeah. Cool.
The batteries are bigger. Or they have a greater volume. Yeah. Because obviously the height difference.
Oh, yeah, that's true. Yeah.
So the actual volume of them.
Sound warning, this is probably going to make noises while I desolder it. I got it. That's fine.
It's like you're trying to kill a witch. One shot.
All right. Okay, so as you can see, we've now made a LiPo-powered doorbell, but the problem is, in order to charge the cell, we'd have to desolder the cell and hook it up to a bench power supply or something else to charge it. Now, the funny thing is, I could probably leave this boy on it, and it would probably last like a year, and once a year, I'd have to disconnect this cell and plug it into my bench power supply, which is probably quite tolerable, frankly. However, just for the sake of the demonstration, this is why one of these little controllers comes in handy, because this means if we add one of these in, we can now make this thing USB rechargeable.
It's also basically the same size as a cell, I didn't realise.
It is. So, yeah, we could actually make a very... Yeah. So B plus is on the back. So if we were smart, let me bring the camera in a bit closer.
Engage manual zoom.
Yeah.
Where Lisa grabs the back of Bart's head and Bart goes, enhance! And Lisa grabs the back of his head and just pushes his face in.
So if we were to jump the cell wires directly onto the back of there, and then we could just tape these two together, and then we just have output and input, that's a thing that I could do. What I'll probably do is I've got that heat shrink, so we just heat shrink it all together, which would be the safest way to do it.
Is that a protected cell?
This is a protected cell, yeah.
So do you actually need this board to charge it?
We need
because the cell protection only protects discharging; it doesn't regulate the charging.
Correct. Yeah. The cell protection. So let's do a super big close up on that protection circuit there. And focus. Focus more. There we go. So that tiny little circuit board on this cell. Here's my little finger. That's my little fingernail for size comparison. So yeah, that tiny little circuit board, that's a protection circuit, and so that's got it's got a controller, which it's a DW09, I think. I think it's a DW09 chip, and the other chip is 2 MOSFETs. And what that does is it creates a protection circuit. So that DW09 chip monitors the voltage of the cell, and if the incoming voltage is too high, it switches off the incoming MOSFET, and if the cell voltage is too low, it switches off the output MOSFET, so it can prevent the cell from being overcharged or over discharged, which basically it protects the cell from being damaged, but also it theoretically protects the cell from going nuclear, because as we all know, LiPo can be dangerous. Saying LiPo is dangerous is a gross oversimplification, but LiPo can be dangerous.
I think the other part of that is the reason why we never had it with like NiCad or NiMi batteries is they just don't have the capacity.
No. Yeah.
They just can't store enough energy.
No. I mean, I'm sure they can do unpleasant things if you stab one while charged or something like that, but probably the worst thing it might do is vent or something like that and just make a... I mean, it might get very hot and go and melt down, but that's different to a LiPo fire. Like a full-blown LiPo fire is heckin' scary, man. you know, because when a lipo goes nuclear, you have what is essentially rocket fuel coming out the back, you know. So we'll just leave that there. Not that we're I mean, this thing is so small that even if this cell went nuclear, it would probably just go. It would probably go Wah! Across the room actually, and be really, really, really funny. However, yeah, but for principle. So yes, it stops it from. I mean, it won't necessarily stop it turning into a balloon because, for example, if you move that guy a sec. Over here, this seems like a really good time to bring in this guy. This is a MacBook Pro battery that I took out of a MacBook Pro earlier on today. And this, focus. So this battery has failed, but if you look at it, only one cell has failed. This guy here is puffed up, but the rest of the cells are actually probably fine. But this guy has puffed up, and the reason why the cells puff up is the electrolyte, which is the fluid inside it, due to... I have read up on why this happens, but I can't remember it off the top of my head. Stop me if you know the answer to this. But the electrolyte, through decomposition in the cell, the electrolyte has turned into a gas. And the gas takes up more space, which is why it is puffed up. It's increased the pressure inside.
Oh, it's the... you end up with hydrogen.
Yeah.
You end up with hydrogen getting liberated from somewhere, and I've forgotten where it gets liberated from.
The electrolyte. I think.
Yes, but as in the actual chemical liberation.
Yeah. Part of that
because
is caused
I remembered looking at it and then going, "Oh yes, this is the chain." And then,
there is a chemical chain. If you wiki search or something like that for lipo failure, you can look up the actual chemical process that leads to this occurring. The point is the cell has failed. As a result of this, it can't hold charge properly. So that means this is what is this? This is a 3-cell battery, and that is comprised of these two in parallel, these two in parallel, and these two in parallel, I believe.
I mean, that would make sense.
Yeah, and because this cell has failed, each one of these cells is 3.7 nominal. And this one has failed, so the voltage on this cell will be very low, and that's dragging down everything else. All these other cells are back charging into this cell, which drags the entire battery down. So that's the failure mode of this. Why were we talking about this again?
Because saying about battery protection stopping.
Oh, that's right, yeah.
Into a spicy pillow.
That's right. So this has turned into a spicy pillow. Yet, well, actually, this has a battery manager on it, called sometimes known as a BMS, a battery management system. Let's peel all of this back. There's a battery management system on this thing. So there's a controller chip there. There's some MOSFETs there. There's probably some stuff on the other side, maybe under. Oh yeah, there's more stuff on the other side as well. And this guy is running this battery. But that much being said, there won't be any individual cell protection. The only protection is at the input-output of the entire battery.
Is it?
Yeah, if you peel that back, it's just a bare cell.
Right, but are the cells then commoned?
Yeah, they're on bus bars, which is what all these weird bits are going around the outside. So the only thing of note is these guys here. I think these are polyfuses. And I think that is very basic protection. So if one of the cells goes nuclear, it can cut power. However, again, if you peel back far enough, you'll just see 2 terminals going in there. And they'll literally just be bare tin tabs.
Yeah.
There you go. There's one of them. So there's the terminal. Let me just go in a little bit closer on that. Oh, that's too close. There you go. And that eventually just goes back to one of the bus bars.
Right, but this one and this one are commoned. Yeah, they're not like this. I mean, there isn't a connector like this coming out of it going into this.
So, okay, balancing. Yeah, so
because obviously with balancing, you can then protect the individual cell using this controller up here. You don't need it placed here.
This is true. Yes, there is balance. However, I don't know I don't know how it works on a hobby cell like that, but the way this is balanced is if you look up at the BMS here, and where's the pointer? These tabs here, this is where the bus bars from the individual cells are coming in. And what we've got is one of these is going to be B-, and that's probably B-, that's probably B+. And then at this point, we've got cell 1 and cell 2, and then B+ is obviously cell 3 because that's the end of the third one anyway. So it has taps from midpoints in it. But obviously, if you go from B- to cell 2, you'll get 7.4 nominal because it's the sum of cell 1 and cell 2.
So that's the point of the extra wires here, because obviously you've got these two that go onto these two, but then one of these should be on there.
So then the question is, if you're going to balance a hobby battery like this, it depends on whether you're measuring from common to a cell or between cells, if you see what I mean.
But if it's like that, if it were connected up like that, you can go from this, the common negative, to that yellow, and get just one cell. Hold on.
That's right.
Sorry if it's that way around. You can get just one cell.
That's right. However, when you're using a balance charger, I'm not sure how it actually measures them. I don't know if it measures between cells or not. It could do, but I don't know if that's how it actually works.
I mean, it certainly gives you per cell voltage.
Yeah. Quite so. And likewise, you can get per cell voltage from these as well. But again, given the fact that that's how they're wired up, I don't know how it... Well, oh no, of course, it just measures between the tap points.
Yeah.
Of course it does. So yeah. So to that extent, this should be able to protect individual cells. But as you can see, we have a spicy pillow in the middle of the battery. So make of that what you will. So I don't think cell protection will protect you from spicy pillows, because that's just cell degradation. That's not from that's just from decay, not because it's been overcharged or over discharged or anything like that. Walking in the middle of the road. Yeah, quite so. NiCad, the top can pop off of the cylinder cell if you short circuit, like a bullet. Interesting, but the fire risk is in lithium with water. Yes. It's worth remembering that in a Lipo battery, the amount of actual lithium in it is minute. I couldn't tell you what the percentage is.
It's also not elemental lithium.
Yeah. So the fire hazard of lithium cells isn't the actual lithium, it's the energy. This is why if you take a completely stone dead Lipo cell and stab it with a knife, nothing will happen. Because when you see it, because there are videos on YouTube of people stabbing a cell and going, oh, nothing happened, see, they're not dangerous. It's like, yeah, that's because it was flat. However, if you take a full charged cell, you know, like if we stab, this cell is going to be at 0 volts. We can check that now, actually. Do you just want to measure the voltage on that cell? Have you exposed the other point? Yeah. Whoop. Let's see what that cell is at.
I'd imagine it.
Oh, there you go. Oh, it's got 3.7 in it. There you go. It's still got something.
Well, yeah. Because it's like with these, these still
down.
have voltage. It's the capacity that's reduced.
Yes, that's true. Yeah. I just expected that one to be dead. However, there's still some... That one's actually still got 3.7 nominal. If I hunted around, I'm sure I could find a cell...
measure off of something like that? Oh, yeah, you can.
Yeah.
Oh, okay.
Yeah. There are other examples where we could find... I've got other batteries where we'll find that the failed cell has just fallen to 0.
Yeah.
Or it's... and if it was at 0 and we stabbed that, nothing would happen. However, this one, there's still 3.7 in there. That might have the ability to do something nasty if we stabbed it. But the thing is, when we stab the cell, what we're doing is we're creating a short circuit between the layers of lithium polymer in there. And because you've got a short circuit, we've been talking all stream about the amount of current capability in this battery. You've now created a short circuit with hundreds of amps of current. That's going to make a lot of heat. And when something gets hot, it starts burning. And when something burns really fast, that's an explosion. And that is why it's dangerous. It's not the lithium reacting with the air, it's the fact that there's so much current flowing through a short circuit that you create fire. And in an enclosed thing like this, where you've got a narrow nozzle for an exit, now you have an explosion. That is what a lipo fire is. Take it out back and stab it. No. I would love to, but I would want to set up for that. We were actually discussing this before off stream before we started. Yeah. We actually discussed this because I've never done it myself, and I've seen.
It's one of those things where it's like, I have these, and I have zero concern about all of these because they're not going to spontaneously do anything. Yeah. All of the connectors are taped off and everything. Yeah. And for actually something bad to happen, you'd need to stab it. It would need to be connected in a circuit. Yeah. You'd need to be actually abusing it in some fashion. It passively sitting on your table or something is going to do nothing. Yeah. Especially when you've taped off the connectors so something can't fall on it and short it. Yeah.
I mean, I've got spicy pillows that have started venting slightly because whenever, like, if I keep them in an explosion containment pie dish. Shout out to Big Clive. And when I open that tin, you immediately go, so, ooh, someone's venting in there, you know. You can smell it immediately. So, yeah. We've got a selection of cells. We could absolutely do a stab test on batteries. But, again, to do this, I would want to set up outside and I'd want to get a paving slab to put the cell on. Yeah. And I'd want to make sure I've got some plyboard or something like that. So if it starts jumping about, it's contained. And we've got a fire extinguisher, but that is something I would set up for. I'm not just going to take this out back and stab it. That's a terrible, terrible idea.
Yeah, absolutely.
So don't do it at my place of business. Yeah. Also, my neighbours don't like me because there's some old... Yeah, I won't go into that. Long story. Anyway. My neighbours would definitely not approve. So we'd have to set up for it. But I would actually love to do that at some point because I'm sure someone's made a video about this, but it would be an interesting video to actually say this is when it's dangerous to stab a battery and when it's not, and demonstrate the difference between stabbing a battery that's got energy stored in it and stabbing a battery that is flat and has no energy and thus will not combust. So yeah. That much being said, if you fully expose the interior layers of a lipo, they can still spontaneously combust. Big Clive has got a video.
It was very much spontaneously combust in the sense of...
Yeah. It wasn't a full-on lipo fire. It just sort of started going... Bleh. Well, yeah, like you said, it sort of went... Bleh. Yeah. There was smoke and there were embers, but it wasn't a lipo fire. You know?
Yeah, absolutely.
So yeah, that the underwear shop. No, I have a good relationship with that side. Moving on. She's a lovely lady.
We have a very good professional relationship.
Anyway, where are we up to? Let's carry on building our stupid doorbell, shall we? I think we've spoken about this. So yeah, we spoke about the protection cell in the battery. So yeah, the cell has a protection circuit on it. However, this protection circuit does not handle charging. That's the thing. We still need a charge controller for it. That's the moral of the story here.
That's loosely covered.
Now I've got another battery that I need to actually be careful with because it's got exposed terminals on it. But yeah, I might actually disassemble that one because there's probably 5 good cells in that I can actually use for things.
It's not exposed now.
Yeah, whatever. Anyway, okay, so let's hook this thing up. So if we're going to do something like that, I'll put that on that side actually, because then I can still see what cell that is. B minus, B plus, and then we'll just fold all of that in. So let's solder those together, I think. I'm going to grab... I'm just going to lean in and grab the thing.
Oh, that. I was looking for the hard drive cover.
No, I'm going to put this in. I'm going to put this in the vise just so it's easier to hold. That'll do. Just set this up. Say something quick. Peace, love, and harmony. Did it. What's so funny about peace, love, and understanding? That's a quote.
Okay, I was waiting for your punchline.
See, the worst is I'm scowling at you for not
The
recognizing
way you said it made it
Yeah.
sound like you were looking for a punchline.
Yeah. Oh, okay. Yeah.
I was just like, continue.
Nope, that was it. That's it. What's so funny about peace, love, and understanding? Okay. Right. Let's tin these up. So we've got holes through these, so I could poke the wires through the holes. We can actually do that for strain relief, but that's going to make it awkward to tie all this together, so I'm not going to. No, those holes are going to take a whole load of...
The concept of love.
And let's go.
JSR would like to know your location.
That'll do. These are not very good connections, but we're gonna glue all this together by various means.
Yes, someone's making a spiritual successor to Jet Set Radio.
Oh yeah, I heard about that. I was never into Jet Set Radio. I know what it is, but I don't have any particular love for it because I never played it.
Yeah.
But it looks like a rad game. Is that vice insulated? Probably not. I mean it's got rubber on those bits, yeah. So yeah. Do you not poke the wire through the hole? We could do, for two reasons, is A, to get a better connection, and B, we could also poke it through for strain relief on the wire. However, my intention... Let me just take that back out again. My intention is to then fold all of this back on itself, so that is flat against the cell like that, which is difficult to do if the wire is coming through the hole. So we can now we'll be able to put that like that and just delicately fold these wires, and then we'll have a nice flat little package. So,
where did that heat wrap go?
Over there somewhere. Where did I? Oh, it's there.
Oh, it's there.
Yeah. Let's keep that on hand because that'll actually be very handy. That might be too big for this. Oh no, I think that'll shrink down actually. I mean, heat shrink goes down by like 2 or 3 times minimum.
Huh.
Oh yeah. Oh, now you've puffed that out. Yeah, it's good enough. Right. Right. That's good to go. So I'm going to put that just there. And actually, we might just do this now and then just have the end poking out. That's a good idea, I think. Let's do that. So let's... how much of that do we need? Let me get... Oh, this is a good excuse to use my new cutting mat. Bought a craft mat. And a scalpel. Or an X-Acto knife if you're American. Right, so that's going to be about... Let's just go for about that much. Is that the right way up? I think it is, yep. Press harder. I don't know how hard to press, so I was a bit light there. That'll do. It's nice and neat. I'm immediately going to put the cap back on this because, my God, you could have an accident with one of these. There would be so much blood. So, okay, right. Are we still in shot? I think so. I'm going to shrink this a little bit and then try and adjust it, I think.
Although, won't you want to put the output cables on first? Because the soldering iron will melt the plastic as opposed to shrinking.
Yeah, you think you're right. Yeah, let's put some output wires on this. So let's use... Let's see, what wires shall we use? I will...
Take the ones actually off of the battery terminals?
Could do. Oh yeah, those are still in reasonably good condition. Yeah, we could use those. I wanted to use something new rather than recycling old wires, but those are actually those are pretty good still. I'll do. Right, and so the problem is now we've got to keep in mind that everything is now live at cell voltage. So we've actually got to be careful about shorting things now. I'm going to tin those holes. And we're going to find out how good this mat is for soldering on as well. Because I could swap this out, but these crafting mats, I legitimately want to know what kind of resistance these things have to soldering. Because I've never found a straight answer as to whether these things are good to solder on or not. Let's see. Oh, God. These are terrible jokes. This is why you're all single.
Wow.
Or some of you, anyway.
Wow.
Look, I say that to defend, just to be like, sort of, these are sexist jokes. However, I know that as long as everyone means it in good fun, you know how it is. Right. Let's go. Bam. And
The amount of shininess you've got on there does not inspire confidence.
oh, what the things I'm making? Yeah, this seems to be damaging this cutting mat. So I think the answer to that is no. This cutting mat is not resistant to soldering. However, this was the cheapest one I could buy from Amazon, so I don't particularly care.
Surely the other thing to test would just be to touch it with the soldering iron.
That's true. Although, given that it can't stand up to that, here we go. Woof. That's the answer to that. No, it is not resistant.
I was implying at the side or something, not in the middle, like here. But no. Oh, the smell. The smell.
It's not bad, actually. Like, not that it's good, but I've smelt worse things that have burned.
Oh.
Like flesh. Or CS glue. Like super glue that's based on cyanoacrylate.
Oh, okay, you're not just talking about, CS gas.
No.
One time I accidentally CS gassed myself.
Cyanoacrylate glue, so just common household liquid super glue. When that burns, if you get that smoke in your eyes, it burns. Like I've had it before. I'm just like, ow, 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 ow. Just like, you got to be really careful with that stuff, man. Yeah. Yeah. Anyway, carrying on. Right, there we go. There's our arrangement. So we can actually do an interesting test with this now. So let's, if you bring in the multimeter, let's just test the setup that we've got here. I'm going to keep doing this every step of the way, just because it shows you sort of what we're doing each time, rather than focus out. There we go. Rather than just doing it all and then going there, done. I think it's interesting to show things every step of the way. So we should find that we've got cell voltage here and here now. Worse than onions. Oh, yeah. Silicon mat. That's what I need, yeah. Can you get onto those? Is there actually anyone at home there? Just try going straight onto the pads there instead of the end of the wires. Interesting, there's no output there.
I thought that was saying 83 volts, and I was just like,
nah,
that's
millivolts.
gone wrong.
Yeah. Yeah, there's our cell voltage. Ah, that's interesting. So that is just an input as opposed to using the thing. So this does not do any protection, but then that kind of makes sense because it can't boost to 5 volts anyway. So there's an interesting difference between this module and a different module you can get. You can get a very similar module to this would basically be a power bank controller. Now, is that what I've got on the back of this? Yeah. Let's just do a quick test, actually. Do you just want to probe VN there, so the red and the black? Hang on a sec, I'll turn that over so it's the right way up for you.
Sorry, that one and this one.
Yeah, that's right. Yeah, that's cell voltage. And I do have that wired around the correct way. No, that one doesn't either.
Yeah, but you've got different tabs on here. You've got 4 tabs here.
Yeah, that's the thing. This is a 4-tab one.
With and 2 tabs up there.
Yeah. I can't remember. I know I've got the correct one in. Oh, I can't remember now. I think the difference is whether the module is providing battery protection and or step up. But at any rate, this guy. It looks like this guy doesn't actually provide any kind of protection per se. It's just a charge controller. So what we would actually do is our output wires, we actually want to be on the battery terminals, and we're going to go sell directly into the Chime. And all this is going to do is just manage charging the cell. I thought it actually isolated the battery, so the battery wasn't directly onto the output, but it doesn't. So but that makes sense because this thing isn't providing this thing isn't providing cell protection. The cell protection is being done on the cell. So the difference, so hang on a sec, I'm figuring this out as I go here. So the difference between these two modules we've got here is this module actually has cell protection on it.
Does it?
Yeah.
Because the pads are right next to each other, so are they not just bridged?
No, they're not. They're actually not bridged. If we go in super close and I focus, this thing's a bit dodgy. There's not enough light in there. However, take my word for it, they're not actually common together. And if you look, there's our old friend, probably a DW09, which is the protection chip. So that guy is going to be handling the protection between the output positive and negative and B positive and B negative. So you'll notice this guy's actually got a lot more happening on it. So this guy here is actually got built-in cell protection to protect, because this cell doesn't have a protection circuit on it. So that is protecting the cell in this setup, and that is our charge controller. Whereas this guy down here, this guy is just charging the cell, but doesn't actually provide any protection on it. So that's the difference. However, I haven't looked at these modules for a couple of years. I've just had them kicking around, so I'd forgotten what was there. But there we go. We're figuring this out as we go. So, I bet you 20 quid you wouldn't get that on a plane. Yes, quite true. So yes, because we're going to be using micro USB, as you say, Mr. Guru, we don't actually want these wires. We actually want to put those over here to go into the chime. So let's adjust this. Let's focus back out again. 1, 2, 3, 4. So let's adjust. I'm going to switch and start soldering on my hard drive now. Oh, actually, I won't, because the hard drive isn't very well insulated. You know, being a metal cover. So I'm just going to carry on putting pock marks in this because this is a cheap mat. I don't care. Whoop. Come on. There we go. Like some more solder will make this work easier. Right, so I'm going to rearrange those now. I will vice the... no, we're fine where we are. Right. So let's go... We're going to want these coming out the back. Are we still in shot? We are. Good. Reflow that. And reflow that. There we go. That's a little bit rough, but that'll do. Who's checking? So going buzzing on every stop. Yeah. Okay, right. So that's now going to go there. Sorry, I read that, got the joke. I was like, ha ha ha. Moving on. So, okay, right. Now we've got that. Okay, so now we're going to wrap this guy.
The piece of shrink wrap that was prepared only moments ago. There was no intermission.
Indeed. Right. So I need to get this so the micro port is just poking out the back. I don't know how I'm going to get this right.
Don't you want it ever so slightly covered because it will shrink?
Probably. Let's go with that. And what I'll do is I'll now hold that like that, and I'm just going to blow in the general direction to get it started, and then I should be able to let it go and finish it. So
let it go.
Hot air. No nozzle. 200 degrees should do it. It shrunk. I'm not very practiced at this, you may have noticed. Whenever it starts shrinking, it always catches me by surprise. I'm like, oh, witchcraft. I'll just heat from a distance here to go slowly.
I'm just waiting for you to go. Ooh, ah, ooh, ooh.
This isn't working very well. I'm too far away from the... Hang on a sec. I'm at the end of the hose's reach.
Looks like an Iceland pizza. What?
The hell kind of pizzas have you been buying? Well, Iceland, obviously, but... There we go. Alright, let's come back over here again.
Oh yeah.
That's not bad, is it?
I'm amazed that given how creased and folded it started.
It straightened out, didn't it?
Yeah.
Yeah, there we go. That's cool. And that's roughly in alignment. Will that push in? It will a little bit, but I don't think that's going to be a problem. I think that'll work. Right, so now what we've got is a USB rechargeable LiPo cell. So let's grab a power bank and plug it in. Check if it blows up. What's that? That's got a type C on it. That's no bueno.
If it just fizzles gently in the corner.
Yeah. I wouldn't be sad if that happened. It'd be really funny. So now, when I plug in this power bank... there you go. So we've got a little red LED on that now to show that it's charging the cell. So if you get the multimeter and if we probe the outputs from that now, we should see that it's charging. I'll disconnect it again so it sags. And let's get arranged. Right, so we're at 4 volts and we should see that the voltage starts climbing. So here we go. There you go. So there's 4.1 and we should find that it's very 4.4. This is probably, there you go, 8.5. So it's going up at millivolts at a time. We're nearly at, I mean, to be honest, that's, by the time we've gone through probing and the wires, that's probably at 4.2 at the cell, which means that's actually not going to climb anymore in any meaningful way. That's actually reached 4.2, and this is now current regulating. But you can see how how that is now charging the cell up to 4.2. And if we disconnect it, because it's still charging, we'll probably find that droops a little bit.
Yeah.
There you go. And obviously, if we left it for long enough, it'll hold that 4.2, but it's still charging. So there we go. Now stab it! So, yeah.
It didn't do anything.
Yeah. Well, technically, you could stab it with an elbow. It's just a very blunt object, I guess. Yeah. Oh, well. Cool. Right, that's that. So now we can hook this up to our doorbell, and we have a LiPo-powered doorbell. So can we fit that in here anywhere? So if we just... that goes that way up. Am I on shot? Let's get this thing out of the way. Was that a... Where's my... Oh, good. I'm keeping track of where the magnet is, so the magnet doesn't suddenly go boom onto something that I don't want it to. Right, so that's going to go in there. I don't think we're going to fit that in there.
The closest you could get is whether it will fit through that hole. That's the closest you'll get to doing something.
I mean, you could close up the back of it, yeah.
Because that allows you to close up the back. Yeah, that's what I meant.
Yeah. Okay. Yeah. Hang on a sec. Let's just show that on camera.
Just have the
So
slider off.
Yeah. So what we could do, we put that, we arrange that again. If we actually poked the cell.
Well, you don't need to really poke it because of the length of the wires.
Yeah, if we actually put it through there, that allows us to then close up the back of the device. Yeah. So yeah. All right, let's solder that into place then, and then we'll figure the rest of it out.
Or if, as that bit's missing.
Oh yeah, it could just come in through the bottom maybe. I need to be careful not to let those wires touch.
Yeah, you're still left with that much of a hole.
Oh, that's part of the part of the catch, though. Yeah.
Oh yeah, but I was just saying you could still have the back on if you went through there.
Oh yes.
As opposed to having a thing sticking out the front.
Yes.
And you could, if you wanted to, make a small hole.
Yeah.
In that catch. or
Yeah.
something.
I'll probably just have it sitting on top, to be honest.
Yeah.
Fine. Okay. Right. Fun question is, what was that about? Let's get it hooked up first.
Capacitor,
Yeah, I was going to say. I just want to see if it does anything funny. I know absolutely zero about what happens if we do that. I just want to try it and just see if something funny happens. It's based on something that I actually saw in school, where we were doing stuff in electronics with buzzers, and I know that there was one there that had a capacitor across the buzzer, and it made the buzzer do funky things. So, use a soldering iron to make holes in the back and feed the wires through from there. Could do, but we're going to feed in through the front because that's where the battery cover is. Right, let's put some more solder on here because we've basically wicked off all of the solder from these terminals. Okay, right, it was red down the bottom. Let's do the black first. So I'm going to just bend this guy out of the way just so it doesn't start dragging across the board. Yeah. And just going to... Damn it. I had it and then I lost it. Heck.
Next week, USB rechargeable CO2 detector.
No. Oh. This wire is not really long enough. We'll figure it out. Right. Ear warning. Noises imminently. Let me turn this around just so I can... Suddenly this feels really awkward.
Is it because the wires are too short?
Noise! There we go. The wires are too short. However. Okay, right. That is on just about. Okay, so I'm now going to poke that through there. There we go. Am I still in shot? Yeah, just about. Oh, no. That wire is not long enough. We're going to have to extend that wire. Oh, that's something. Or we could just close it up. Oh no, I wanted to... hang on a sec. Okay, so that's how it will go together. However, capacitors and stuff. I want to see what happens. Right.
Have you got different capacitors?
I've got some big electrolytics, but I'm beginning to think that these guys are probably way too big. What are these? These are 6.3 volt, 820 mic. These are probably way too big to actually do anything. But we'll see. Add a solar cell and it's self-charging. Probably would be, actually. You probably wouldn't need an enormous solar cell.
No. Just a little calculator.
Yeah, I mean, probably something a bit bigger than that, because those will be milliamp. Well, like singular milliamps. But, right, hang on a minute. This probably needs to be... I don't know what I'm doing here. I don't know if anything is going to happen. I'm just curious as to what will happen. Where are my cutters? I don't know where they've gone. Fine, I'll use these ones.
Whee.
Right. In no particular arrangement, that needs to be shorter. In no particular arrangement, because this is an AC circuit. Here we go. I need to solder it on there. That's not working. I don't think this is actually going to do anything, but that will result in no sound. Yeah, do you reckon it's just going to absorb it all? It's probably too low power for this. Like the last time I saw this, it was on a big old buzzer that was probably significantly higher power than this piezoelectric. And I think I would need a much smaller capacitor. Because, yeah, what I'm trying to do is that the capacitor would modify the waveform and make it go wobbly, which is why it would be funny. However, again, I don't know how to calculate. Oh my god, can you just solder on there? There we go. However, I don't know how you would calculate the required capacitor to get that effect, which is where this will go wrong. But as I say, sometimes it's curious just to do something daft and just see what happens. Ow, there we go. So yeah, presumably this is probably going to just mute the whole thing now, but let's find out. Yes, that muted the whole thing. So yes, yep, fair enough. More flux, yeah. Wrong polarity. It's an AC circuit at the piezoelectric, though. No, piezos are polarized, aren't they? Of course they are. But it's a... I'm at the edge of my knowledge here. Is wobbly a technical term? Yeah, the capacitor is definitely too big. Yeah, to make it wobble, you need more. Maybe. Let's hope it still works. Oh, it'll be fine. Oops. You doubt it. Next week, soldering random stuff together. Yeah. Bare piezos are not polarized. Oh, there. Yeah. Why are piezoelectric speakers, when they're beep speakers on computers, polarized then? Oh no, they've actually got little circuit boards on them, haven't they? So yeah. Am I a doorbell repairman? If you call this repair, then yes. However, my capacitor idea is going nowhere, so I'm going to abandon this now. It was a thought. However, this is not progressing us, so I'm immediately going to abandon this train of thought because they have signal generation for the beep. Fair enough. Isn't that not made by the motherboard then? I suppose so, yeah. They've got tiny little oscillators in them. Yeah. I broke it, so now I'm repairing it. Something like that, yeah. Yeah. Whatever. Let's put this thing back together
Repair it
again.
Until it's broken.
Yes.
Just like those VMUs.
Look, we don't talk about the VMUs.
Have you got any working ones left?
Yes, however, my Dreamcast ended up being dead anyway. Was there screws? Yes, there were screws in this.
2.
Right. I'm blocking a screw hole, so I need to adjust wire. Yep, however, unfortunately, my Dreamcast ended up being dead anyway, which I was incredibly sad about. I'd have not bothered with the entire endeavour if I'd known the Dreamcast didn't work.
It's alright, you can get another Dreamcast.
I could, but I don't know if I want one, to be honest.
What did you even want that one for?
Sorry. Just to play some old games on, really, because I've still got some Dreamcast games. I was going to have it just set up in
why do
here.
you not want another Dreamcast to play some old games on?
I don't know. Stop asking difficult questions. So, get an emulator, pretty much. Anyway, LiPo-powered doorbell. We did it. Noise warning. Here we go. There we go. And it's also now USB chargeable. So we can now plug this in the right way up. And it's charging. There's a little red LED on it to indicate that it is charging the LiPo. Other side.
Oh. Does it?
Didn't really make a difference, no.
No, I was wondering if
yeah.
it would stop it charging or anything like
Oh,
that.
right,
or
yeah.
The charging would stop it working or
No,
anything weird.
Yeah. No, you can use it while it's on charge. Although, obviously, that would do some interesting wobbly things to the thing if you drag down the voltage slightly. Although...
Yes, things to the thing if you do the dragging.
Yeah. No, I don't know. I'm thinking, but yeah, I'm not sure. Oh well. USB power bank with solar on it. Could do. Ultimately, what would be interesting to see is Paul Daniels was modifying his Chime too. I'm not sure if you're joking or not. Oh, you're using a USB power bank with solar on it. Oh, did he actually? I did not get this idea from Paul Daniels, first of all.
This was something that was spoken about
Yeah.
a week ago, 2 weeks ago.
This was a unique idea.
Because I kept complaining about the...
Yeah, because the battery has been going for weeks now. It's been slowly sounding more and more poorly, up to the point where you saw how it sounded at the start of this stream.
You saw how it sounded.
Shush! Shush! He was changing his tones 3 weeks ago. Oh, okay, yeah, fair enough. Oh well. And on that bombshell, we come up to the 2 hour mark. I don't know. Is there anything else we want to mess around with?
Not explicitly.
Yeah. What have we learned today? Well, I hope you guys have learned some interesting things about lipo cells and stuff like that. So yes, I hope you guys have found this kind of interesting. Solder a plug socket in that thing.
Randomly 240 volt.
Well, it needs some way of disconnecting, I suppose. But yeah, ideally, ideally it needs to be modified to have longer cables on it, because, well, that works. I'm basically sitting here thinking, how much do I actually care? Because it sits above the door, so yeah. Make a hole under it and second case attachment. Yeah. You've learned more about yourself watching this episode. Oh no. Let's see the map burn again. No. I'm not going to burn it on purpose. Anyway. Yeah, are we done?
Sorry.
I don't know.
Yes.
Yeah. I think we've kind of finished this up here. Nobody's going to touch it up there. Yeah, basically that. Now design a 3D printed case for it. Yeah, I think I'm trying to decide whether I can be bothered to extend the cables on there. Because what I might do is, it might be worth taking that apart again and just sticking this JST connector in line, just so this can be just taped to the side of it and it can actually be disconnected. I'm actually going to do that. That's the sensible thing to do. Because then it requires me to store this somewhere. But this thing has been wrapped, so it's actually safe just to leave that hanging out somewhere. So yeah, let's JST it. It also just means, nothing's going to happen. But if it did happen, I can actually disconnect it without having to rip the thing out. So yeah. Okay, right. Let's do that.
Magnets, how do they work?
That's a good question. That is a good question. Sorry. I think there's a bad connection in there.
Anti-tamper device.
Yes.
And by anti-tamper, I mean it will just randomly go off at you.
And turned your volume up. Solar flares from this week. I don't know. Everyone was talking about that. I don't think anything got damaged. Although did anyone hear of any damage from the solar flares? I heard that those were a thing. Don't know anything about it though.
All I saw was one person saying, "It's the end of the world.
Yeah.
There will be no more electronic devices."
Yeah, and it was
me
just like,
going,
"Yeah, sure."
What?
Yeah. And the rest of it. It's not the first time we've had solar flares. I can't remember when the last time was, but every time one comes along, it's like when winter comes around and all the tabloids have got Britain to be blasted by minus 20 degrees snowstorms. And it's always the same every year. And whenever there's a solar flare, it's just like planes are going to drop out the sky. And it's just, they'll be fine. Do you really think that they are not shielded against this kind of thing? Do you genuinely believe that the designers of these things have not considered solar radiation?
It's also the fact of we have an ionosphere.
Yeah, which cuts out most of it.
We had a magnetic field.
Yeah.
The planet has a magnetic field that cuts out most of it.
Yeah. It can be detected, but I don't think it's enough to actually affect anything meaningful.
I mean, it may
unless
be...
you have a device that's hilariously unshielded.
I mean, it made the...
Oh my god, can this thing heck off?
Aurora Borealis more...
Yes.
Visible.
That makes...
For a much greater...
yeah.
A further distance south, even.
The Aurora Borealis at this time of year in this part of the country, situated specifically in your kitchen.
Yes, precisely so.
Next week on Rechargeable Junk Mods. I think doing stuff like this is hilarious. Don't at me. Do either of us have a 3D printer? No, I want a 3D printer, but I don't need one, which is making it very difficult to justify spending the money on one. Because I would just print bollocks on it. Not actual bollocks, but...
just prints testicles.
Yeah, I would just print pointless figurines and stuff like that.
Oh, Fluttershy.
Like, the problem is there are certain times where I've been fixing something and I'm like, oh man, if only I could 3D print the replacement part for this. But the problem is I don't think I would be able to afford a 3D printer that would be capable of printing sturdy things. I would end up with just a cheap one. You did print a plumbus on request. There you go then, yeah. Yeah, Chris S said it. Can I see it? No. Okay, right. Let's put the gist on this.
I don't think those cables need to be that long.
I don't think so either. Let's shorten those down. You're right. Are we even in focus at the moment? I'm not sure. I'm going to go a little bit closer. There we go. Heating in an oven and cool it makes it stronger. That would make sense.
Oh, the 3D printing, not
yes.
not the JST connector. Right, understood. Very good.
No, I don't think a JST connector would enjoy being in the oven.
I don't think it could ever be described as strong.
No, they're a bit crap, these, but they do the job. They did. Oh, I put it away.
Where did my soldering iron go? Oh, it's in my hand.
UV resin ones are getting cheap. Yeah, I mean, you can get a 3D printer that's worth owning for about, for £300-ish.
For less than it cost to buy a mobile phone.
Yeah, which is depressing. So, they're not super expensive, but at the same time, that's £300 that I could be spending on the rent, That's
£300 I could be spending on the 3080 Ti.
Yeah, I already did. No regrets. Not that I needed it, but just simply because I hocked my 3070 for £900. Bloody miners, man. They might be a pain in the arse, but hey, they paid for my 3080 Ti, so that'll do nicely. Right. Okay. I'm going to captain tape those. Heat shrink on the cables. Yeah, I don't have any super small heat shrink, so I'm just gonna captain tape them. A very precise cut, and immediately put the thing on there. Right.
Yeah, knives and stuff kind of stop seeming sharp to you when your friend has actual medical grade scalpels.
Oh,
and
man.
It's just like, I'm using these for building my polystyrene 3D models.
God, they must be terrifyingly sharp, those things.
Yeah, and I'm just like, ha! Do not.
That'll do. There we go. Hot melt glue. Oh, that would... Oh, damn it. I wish I'd thought of that. I mean, it's not too late. But that'll do. Captain tape falls off. I never have that problem. Legitimately. I never have issues. Not with this stuff. I've had this same roll of captain tape since I got into doing board level repair. And it's great. Like, literally, this captain tape, I do not have any issues with it. Noise warning. There we go. Just look at the craftsmanship. It's a thing of beauty, isn't it? Joy forever. So we could poke a hole in that or cut a cutout, but would there actually be any benefit to that? We could. We'd put a little. We put that to there. I think that could be done actually. Let me find my hacking cutters, my side cutters. So I think if we just nibble a bit out the side of that, there they are.
I mean, you could still go through the hole that's already there.
The problem is that hole lines up with that notch.
Then you know. Oh, I guess to keep it on there.
Yeah, and it won't. The thing won't close properly if we cut that notch out. So I'm deliberately going to make a new notch over here that doesn't interfere with that. I'm now just going to nibble that out. For a moment, I thought I was about to just cut straight through that wire and be like, oh, I just ruined everything.
Everything is awful.
Okay, right. Where's that correspond with? Close to the end. Probably about there. You got a doorbell wired directly to 220 volts. That's the way it used to work. Although I never did. We always had a battery doorbell in my house. Took big old D-cell batteries.
I presume ours is mains powered.
Yeah. And when
I have
those
actually no idea, but
yeah. Because the way ours used to work is, yeah, big old D-cell batteries powering a solenoid, which lifted the striker up into the high note and then allowed it to fall onto the low note. And when the batteries were getting low, it couldn't lift it high enough, so it would just go ding instead. Right, that fits over, but it's not staying on. It might just be that it's too tight a fit. Oh, there we go. That did the job. Haha! Done.
nothing like a bought one.
Yeah. That's what a normal doorbell looks like, right? That doesn't look like some kind of death trap. Does the sun hit the door? Ooh, not quite, because the door is recessed. However, the shop is not in the morning. The shop does get direct sunlight, so we could legitimately solar power charge that. That's actually a very interesting idea. How many solar cells do you need to get up to 5 volts?
I don't know.
Yeah,
I guess it depends on the technology.
Yeah, what's the standard solar cell? 1.2 volts or something like that? Hot glue the lid on. No, I want to be able to take it off again. Does it say Friedland on the case? Yes, that's the brand of it. So yeah, solar cell will work from lights too. That's true. We've got a lot of light, but yeah, because if a solar cell can, I mean, a USB power, a power bank would be overkill. We've literally got a battery in it. Benchmark it now. I think we might have gotten up to 3 or 4 hertz then.
There certainly was a lot of hertz.
Solar cell from an old calculator. You only need a trickle charge. We've got to get the voltage up high enough though, right? Otherwise it just won't do anything. The voltage needs to be high enough to actually push that current into the cell. So we'll make a remix of it.
Oh dear.
Grab a Poundland garden light. Yeah, that might work. Get a portable solar power pack to power phones. Yeah. Again, I don't want to buy something that has value, though. That's the thing. Can you play Sandstorm out? I'm not going to try that. However, I feel like this stream has peaked, though, so I think we should wrap up. because also for once we've done what we set out to do. I feel like that was a fairly good stream as well. I feel like we learned a lot about Lipo battery cells along the way. That's how you get swatted. Yeah. Cheapo's $10.
That's a lot of money for something that's utterly pointless.
Yeah. Well, it's only $10, but also I don't care about it.
$10 to stop you from needing to charge it once a year.
I don't know. That will be more interesting, is how long this lasts. What I'm going to do is I'm going to charge it up fully. I'll leave this on charge.
Are you going to write today's date on it?
That's probably a good idea, actually. Yeah. Let's hang on a sec. Let's grab a pen.
Do you not have an indelible marker?
I've got a Sharpie, but I want to be able to rub the date off again afterwards.
You have IPA?
Yeah, I guess. Or I could just write it on a little bit of masking tape and put the masking tape on the thing. So, where are we today? 1610.
16/10/21.
1610.
I'm being optimistic.
Also, I'm not sure that this pen works on this tape either.
I mean, there's a Sharpie.
I'm going to get an indelible marker. Because, like, why would you not just use an indelible marker in this situation? So I started firing wildly. 16, 10, 21. Also, now I understand what your remark about being optimistic now as well, by virtue of the fact that we're putting the year on there. Yeah. Right. Just about. I thought I was going to lose half of it then. Work of art. There we go. So, I'll charge that up, and I'll see how long it lasts. So, yeah, don't bug me about this next week. There we go. It just finished charging. It just clicked over to green. So we'll now find that. There we go. It did it. It worked. I thought that was going to be blue, but yeah, no, it's a green. Cool. Right, that's fully charged. So, yeah, we'll leave that and we'll see how long it lasts on that battery. Because if that lasts for like, I mean, even if it only lasts a month at a time, all I've got to do is just, like, that cell probably charges in half an hour. Or actually, this is probably banging 500 milliamps into it, so it'll probably charge in about 15 minutes. So just
charged in 4 seconds.
Yeah. Oh well, it wasn't flat, Noah. It was yeah. We were already at like 90% charge, so it just needed to top it off. So yeah. Like once a month, I probably just got to disconnect that, walk over to my USB charge station, and leave it plugged in for 10 minutes. So yeah, there we go.
Excellent.
Oh, yeah, that's it. So that is the USB rechargeable door chime, everyone. Thank you for joining us on this adventure. I've enjoyed this adventure in English, I think.
This something in something.
Yeah.
It has been
a stream. I thought this went as well as I expected, to be honest. This stream, I think we
meets expectations.
Yes, this stream was par. Kind of wanted to see me make a UK plug to USB charger. I'm not messing around with main stuff. So yeah, main stuff is scary, man. I'm not going to mess with it. It has been.
It is.
Yes.
It was.
And will continue to be. Battery cells probably last 10 times longer. Might do. However, this is rechargeable.
We shall see.
Yeah.
Because the data's on there, we will now be able to find out.
Yeah, we'll find out. I mean, that's the other problem as well, is that these old cells that came out of it might have been 2005 cells, because that was the date code on this thing. So these things might be 10 years old, and if I just put fresh cells into it, the fresh cells may have lasted 2 years.
Although, given the fact that they were dropping off by nearly 2 volts.
That's a good point, actually. Yeah, when we tested those, the voltage drop-off was massive. So yeah, it's entirely possible that the new ones would not have lasted any, longer than 6 months either. So yeah. So yes, I think this was valuable. I think that there was value to this. If nothing else, because it's chargeable, it probably doesn't even matter anyway. And if it's crap, I'm just buy a new Chime. So,
Well, you need a wireless one, don't you?
yeah, I actually, in all seriousness, I want to get a wireless Chime anyway. But
You need to set up a Pi Zero to publish the charge percentage to the internet.
if you want to write the software to do that, Teltac, I'm dead
also,
serious.
And also dig out the Pi Zero from somewhere.
Yeah, Pi Zero's what?
You've
couple
got
of
one
dollars.
Somewhere, haven't you?
Yes, I do.
Using one for a Game Boy mod or
Yeah,
something.
I was making a Game Boy mod, but it fell through though, just because I was figuring it out as I went, and like it got to the time where I'm just like, I need to start from scratch for the third time, and I kind of just got bored of it, you know. So yeah, but yes, legitimately, Teltac, if you were to make the software for that, I would legitimately rig that up so we had an Internet of Things, Pi Zero, to report the status of the door chime, and then we'll put out another challenge to see if someone can hack it. Like, I don't know what would happen with that. We'd have to DMZ it. We'd legitimately have to, or just we'd have to put it on a VLAN because it'll get hacked. But yeah, use an 8266 instead of a Pi. Yeah, potentially. I don't know anything about programming on that front, so I wouldn't be able to. I don't know what would be the best option for that, and I wouldn't know how to make it. So yeah, doorbell starts playing chip tunes. Also record how many times it's chimed. You could do, because you could monitor the battery voltage, and if the battery voltage dips slightly, you know that the door chimed. So that would legitimately work.
Anyway, we're leaving. Goodbye.
We are leaving. Thank you for joining us, everyone, as always. See you next week. I don't know what we're doing next week.
We never know.
We never know. We'll think of something. I'm very tired. Right. Yeah, no, seriously. Thanks for tuning in, everyone. We'll see you next week with something. We'll find something. I can be the new EV blood covering his solar panels. Yeah. There's something funny about doing pointless things to me, and having pointless monitoring things, and internet monitoring of the status of my door chime. That is very funny to me. Wi-Fi clothesline. See you next week. Bye, everyone.
Goodbye.